The volume to mesh modifier shows up in the modifier menu when selecting a mesh object. However, the mesh to volume modifier only shows up if you have a volume object to select. In order to best explain what the volume to mesh modifier does, let's first take a look at the mesh to volume modifier. I have here a very high resolution scan of a clay dragon. I've added a sun lamp to the scene, and I've given this dragon a principled volume shader. The mesh to volume modifier can only be applied to a volume object, so let's add one. I'll hit Shift A to bring up my Add menu. I'll select a volume and then select Empty. While this empty object is still selected, let's go to our modifier properties. Only modifiers which can be applied to a volume will show up here. We'll select the mesh to volume modifier. Under the settings, we'll need to select an object to create the volume, but so that we can see this effect more easily, I'll make sure that the dragon will be hidden when it's rendered, and in its object properties, under Viewport Display, we'll set the Display As for this dragon to Bounds. This is handy since it will show you the boundary inside which the volume will be constrained, but it will not show the dragon mesh. I'll select the volume object from the outliner. I'll eyedropper select the dragon's bounding box. It might take a second, especially if the object is extremely high resolution, like this one, but you'll see the volume has now taken on the shape of the object. I'm using the Cycles render engine for this particular demonstration. Let's toggle into Render Display. Now I'll have to hide the dragon object in this mode, but you can see more clearly how the light I've set up in this scene interacts with the volume. Let's take a look at some of the settings we have available to us, which will help further adjust this volumetric shape. First, we can adjust its density. Naturally, the higher we set this factor, the more opaque the volume becomes. If we untick Fill Volume, you can see how the voxels are distributed inside the volume of the mesh. You can think of a voxel like a cubic space, in much the same way a pixel occupies a square, but in 3 dimensions. Before we re-enable the Fill Volume option, note the 2 settings below it, exterior and interior bandwidth. Currently, both these settings are active. The exterior controls how far the gradient will extend outside the mesh, or in this case, the voxel. The interior controls how far inside the gradient will extend. If we enable the fill volume once more, only the exterior bandwidth is active. We have 2 resolution modes. Voxel amount counts the number of voxels generated along a single axis of the overall volume. The higher we set this, the smaller the voxels are. The effect appears as though the mesh is more faithfully represented because the resolution is higher. Voxel size works in reverse. It will calculate the size of the voxel first, then will fill the space according to how many voxel it needs to fit along that axis. So now let's see how this can work in reverse, or by using the volume to mesh modifier. We can apply this modifier to any mesh, so we may as well stick with the default cube. In our modifier properties, we'll add the volume to mesh modifier. The settings appear similar to the mesh to volume modifier, and the cube appears to be hidden. This is because it requires a volume to reference in order for this to work. This time, I'll add an OpenVDB file from the drop-down menu. An OpenVDB file is something that holds volumetric simulation data and can only be imported into Blender in this way. The axis of an OpenVDB file is usually Y up, and the scale might be quite large, so rotating and scaling the volume might be necessary. However, we saw with using the previous modifier, any translation, rotation, or scaling will be reflected in the resulting mesh. I'll set the viewport display for the volume to bounds, and I'll disable it in render view, so that this object remains hidden at render time, but is still selectable in solid shading mode. Now with the cube selected, we can use this object as the volume to reference. A generated mesh will appear, taking on the approximate form of the volume. For this modifier, there are 3 resolution modes: grid, voxel amount, and voxel size. The grid name is imported from the VDB file. It usually references the base grid that is already packed into the VDB file, which in this case stores density values. When the resolution mode is set to grid, it will use this imported base grid distribution of voxels in order to generate the resulting mesh. The voxels can vary in size according to the density, hence why this mesh can appear to have finer details in some parts. The threshold refers to the size of the voxels which will be included or excluded from the volume. Decreasing the threshold will allow finer detail present in the base grid to be included. If we increase this threshold, less and less voxels make the cut, until no voxels are left to generate a mesh. Results can be quite dense at low thresholds, so you can slide the adaptivity from 0 to 1 in order to reduce geometry in places where it's not needed. You can also enable smooth shading should you require it. The other 2 resolution settings are voxel amount and voxel size, and they work in much the same way as they did in the mesh to volume modifier we saw earlier. The amount refers to the number of voxels that will be generated along an axis, and the size refers to the generated voxels dimension. The less voxels that are present in a voxel amount, the lower the mesh resolution will appear, and inversely, the smaller the voxel size, the higher the resulting resolution appears. In both cases, the threshold and adaptivity work in the same way as they did for the grid resolution, by increasing or reducing the number of voxels permitted in the volume, and by reducing the amount of topology generated when it is not required.